Hello to everyone and welcome to our cloud coaching session. Today we talk about how to simplify microservices architecture. And we have a special guest as Victor Mendo, who is our data development specialist, and Herman Viscuso, who is the director of the community management of Oracle Autonomous Database. We saved 2 hours for this session, so bear in mind that this is an extended cloud coaching session. So session 1, we talk about Oracle Transaction Manager for microservices with Victor, and we saved about 50 minutes or so for both presentation and demo. Bear in mind that Victor will show you some cool demos. And then it will be a 5-10 minutes break between the sessions, and we will have Herman, who will show you how to upgrade your microservices or Oracle Autonomous Database. And Herman has also prepared a cool demo for you to showcase today. I think that was all on my side. I would like to invite Victor now.
Okay, so thank you and welcome everyone to this session about simplifying microservices with Oracle Autonomous Databases. In my slot, I will speak about transactionality with microservices, and I will introduce you to MicroTX or Oracle Transaction Manager for Microservices. It's the same, different names, or even OTMM, that it is the acronym for this service. Based in the poll we have run at the beginning, you are mainly familiar with events more than with this kind of solution about transaction coordinators, so I hope it will be interesting for you. So let's start with the presentation. Well, let's start defining what are the challenges that we are facing when we are working with microservices and with the data consistency. So perhaps a good starting will be, why is data consistency so necessary? That's something that I don't need to explain too much, because it is very common in any company that you need to have some data consistency across different data stores or databases. For example, in finance, of course, if I try to send money from one of my accounts to my parent accounts, for example, and the account is not in withdraw from my account and doesn't appear in my parent account, then I will be very angry with my bank, of course. Or if I'm doing something like go to an e-commerce and buy an item, and you confirm me the order, but you don't have enough inventory to serve me this order, I will not be very happy for the delay, or you will need to call me and cancel the order because you don't have enough items to serve me this request. That's very simple to understand. The main issue is that we are trying to update two different data stores, two different bank accounts, two different the order database versus the inventory database. So this is a dual write problem that we will try to solve using our MicroTX. Okay, so in the past, we were running most of the company's monolith applications. So we have a huge code base, and we have only one database, perhaps 2 or 3, but we have only one monolith. So it is, let's say, not so easy, but quite simple to try to maintain the data consistency across different databases. When we are moving to microservices, now the problem is becoming bigger. That's one of the cons of using the microservices architecture. We will have one data source per each microservices, and probably a business transaction involve more than one microservices. This means that we need to take care about if we are updating one database and we have a second database related with data related with the first one. Okay, we will try to update both with the same or data of similar data. What happens if I'm able to write in the first database, but I got an error in the second database? Then I will need to roll back, but I have not a distributed transaction here, so I need to figure how to do that. Oh, okay, that's not so easy right now. We had, there are a lot of patterns that will help to try to solve this situation. For example, I think that the most popular one could be the Saga pattern. So we can implement those patterns, but it requires that our developers start writing more and more code. And being honest, when you have only 2, 5, 3, 4 microservices, like in this picture, probably it will be easy to do. But as soon as the microservice architecture start growing and we are adding more and more microservices, we will find that it is quite time consuming, not so easy to implement, and we will need to maintain it. So it is a very interesting, one of the issues we are facing right now with the microservices architecture, and one of the main points customers are coming to Oracle asking how we can solve these kind of problems. So let's look into the transaction manager for microservices, MicroTX, OTMM. Let's see what is it. So Oracle Transactional Manager for Microservices, it just enables the developers to use, let's say, distributed transactions to ensure data consistency across multiple microservices in our architecture. We are not using nothing new, so we are going to use the standards we have in the market. We are using XA, we are using long-running actions or Saga patterns, and we are using also the try config cancel patterns, that it is probably the 3 most popular patterns in order to manage the data consistency across microservices architectures. Of course, if we are releasing this MicroTX, we hope that this will be a polyglot, or should be able to be used with polyglot applications. Doesn't care if we are developing with Java, Node.js, whatever. Our target is that you can use this MicroTX. Of course, you can use any platform. You can use Helidon, you can use Spring Boot, you can use whatever. And that's today demo will run with autonomous databases, but we are also supporting heterogeneous resource managers. It could be with MongoDB or any other databases that you could have in your architecture. Microservices are not alone. We have still some legacy applications in our data center or even in the cloud that we will need to interact with the microservices. So MicroTX also enables microservices to work with other existing applications that are not following the microservices patterns. Okay, and of course, it is to be deployed on Kubernetes. Let's see a little bit about the components. MicroTX has mainly 3 components. The first one is the transaction coordinator, that will be a container running in our Kubernetes cluster. We have also a graphic interface that it is the MicroTX console that allow us to check the health status of the coordinator, also allow us to check how many transactions we are running, what is the status of those transactions, and get more information. Even it allows us to interact with the live transactions. We can cancel or we can terminate one of those pending transactions. And of course, we have a MicroTX library that it is the library we will import in the microservices which are going to participate in the transactions. It will simplify a lot the development, and we will see during the demo some code, and I will show you how easy it is to use these libraries. And of course, also the coordinator and the console are microservices themselves. So they are running in the Kubernetes cluster. We can scale up our coordinator if we need it, no problem so far. And the communication between the participants in the transaction with the coordinator is based on REST. So we don't have special requirements in order to change your applications to be using this MicroTX. if we are working with transactions, I suppose that it is quite important for you and your business. So probably we need to recover in case that we have any kind of problem with our coordinator. So we are able to persist the transaction state to etcd or to the Oracle database. This means that if the coordinator goes down, then we can start up again the coordinator and recover the transaction status of any transaction running in the architecture. Okay, looks simple. Only 3 components, easy to deploy, easy to use in the applications, as we will see later. So what are the main benefits using MicroTX? So first point is we are going to reduce the application complexity. I will show you later in the demo some code, how to import the libraries, how easy it is to start the transaction, and you don't need to change your code in only adding some annotations or importing some libraries, but very easy. At the end, it will increase the developer productivity. Developers don't need to take care about how to solve the transactions failovers or the whatever you need. The coordinator will take care about rollback and one microservice if the other fails, whatever you need, the coordinator will do, so the developers will focus on the business. Okay, so we are not using nothing special. That's based in industry standards, so very easy to understand, very easy to implement. At the end, if it is simple, you are reducing the time to market, so you will have your application in production faster than trying to solve yourself the problems with the transactions. Okay, so let's move forward and let's see what are the current patterns we are supporting with Transaction Manager for Microservices, MicroTX. As I mentioned before, probably the most popular patterns to deal with data consistency in the microservices architecture is the Saga pattern or long-running action. MicroTX includes support for long-running actions, implementing the Eclipse microprofiles long-running action specification, again, based on standards. And in this case, we are seeing here the trouble booking. I will run this example during the demo. That's very simple. We have a trip manager starting a long-running action. It will do through the transaction coordinator. The transaction coordinator will take care to join to the long-running action to the different participants that will be the flight booking or the hotel booking. And of course, when we need to complete the long-running actions, we will do it through the transaction coordinator. Okay, very simple. We will see in the demo. Second patterns we are supporting is the reservation model. In this case, it's like, again, the example here is again a trip booking. In this case, this is more the long-running actions. The previous one is more when we are dealing with our internal microservices architecture. In this case, it's more when we are dealing with external providers, for example, travel agencies and so on. So in this case, we have the trip agents. It will reserve the room or reserve the flight ticket, and when he wants to confirm or cancel the booking, he will do it through the transaction coordinator. So that's very, here the consistency is lower, but it's another pattern supported by the transaction coordinator. Finally, we have the XA or distributed transaction support. This is something that is very interesting because it is difficult to do in a distributed architecture like microservices, but MicroTX support this protocol with a strong data consistency across microservices, and we will see it also during the demo. In this case, the transaction, we will have one microservices starting the transaction, then it will invoke to one or more microservices. Those microservices will enlist themselves in the MicroTX coordinator in the transaction. We are doing that propagating the transaction context. I will show you in the next slides. And at the end, the transaction coordinator take care to follow the phases in this XA protocol to prepare the transaction. And when everyone, all the participants are ready to commit, or they will commit, and if any of them has a problem, then the transaction coordinator will send the rollback command to the other participants. Oh, that's great. Do we have the same consistency we have in our monolith, but right now we can archive the same consistency level using our microservices architecture. But that's interesting because how we can do it, because, you know, if we have the transaction coordinator sending prepare, commit, rollback to the resource manager, the main issue that other products are facing here is that, okay, in the transaction manager, we will need to include the libraries for the different resource manager types. That means if you are dealing with Oracle, you will need Oracle drivers, and you will need the user and password in order to access to the resource manager. Or if you are dealing with another, I don't know, DB2, for example, you will need here the drivers, and again, you will need also the credentials in order that the transaction manager will invoke the resource manager. How we are dealing with this problem? Okay, we are using a proxy or manager proxy approach, resource manager proxy approach. What we are doing is just adding in the library, the MicroTX library that you need to import in the transaction participants, and it will act as the resource manager proxy. So we are sending all the commands through this library, and we don't need direct access to the resource manager. So at the end, in the transaction manager, we don't need any specific configuration to access to the remote resource manager. This simplifies a lot of the architecture, the configuration, so it will be very, very easy to implement. Okay, that's about the architecture, the patterns we are supporting. Let's see a little bit how we are simplifying the application development. 2 slides. And then we will see later some code in the demo. So we are using interceptors to simplify the application developer. At the end, it is great because you don't need to add more code. We are propagating the transaction code to the transaction participants using these interceptors. You don't need to add any other code, so it handles automatically the enlistment of the participants in the transaction coordinator. Great, simple. You will see an example later in the code. And of course, we have some flexibility also in order that you can choose your programming language. You can use right now Java, TypeScript, Python. We are increasing the language we are supporting right now in the preview in the next releases of TMM or MicroTX. And of course, you can choose your development framework. We love Helidon, but we have also for Micronaut, and probably the most popular microservice framework right now will be Spring Boot. And of course, again, we are based on the standards, so you can choose the standard you want to follow in your application with the Spring REST, with just the patterns we already comment, XA, long-running actions, try, config, cancel, or JPA, Hibernate, Eclipse Link, whatever you want, that's available. And as I mentioned before, probably your new microservice architecture will need to interact with your existing applications already in your company. So you could be running applications on WebLogic, you could be running applications with transactions through Tuxedo, whatever you need. We have some interoperability with those components that allows to those legacy applications to participate on the transactions managed by the transaction coordinator. So that's great. We are not alone in this microservice world, so that's allow us to increase the scope of the transactions to the existing applications we will have in our organization. Okay, that's cool. we have three slides more for the demo, but they are also quite important because if we want to use it in our microservice architecture, we need some enterprise capabilities. So the first one is to be able to scale in order to for pick loads or increase the capability of the transaction coordinator. As I mentioned before, it is a pod running in the Kubernetes cluster, so it is really very easy to scale. As any other application running in Kubernetes, you only need to change the number of pods in the descriptors or the Helm chart, and then apply it, or even we could have the on-demand scaling if you want to monitorize your performance, and then if you need more performance, you can increase the replicas. We are recommending 3 replicas just for high availability. With one, you can have an issue, and then you can persist the transaction status to the database, but we are recommending 3 replicas to avoid issues. Okay, so second point is also the transaction resilience with MicroTX. As I mentioned before, we can persist to the Oracle database or to etcd. We are recommending Oracle database for production environments. This allows us to recover the transaction in case of the coordinator failures or restarts. And also, it could happen that the coordinator is not available, or when a transaction starts, one of the participants is not available. So the transaction manager also includes some retries, auto retries, to reconnect in case of the transaction participant failures or coordinator reachable issues. That's great. Security is also a key point. We are supporting all the requirements for a company could have around the security. We have mutual TLS between microservices and MicroTX coordinator. And of course, we can secure for example, the participants who require a token validation in order to join to the transaction or to connect to the transaction manager. And for that, we are supporting different identity providers. Of course, the OCI Identity Cloud Service or identity domains. We are supporting also Microsoft Active Directory, or we are supporting Kcloak running in the Kubernetes cluster. That's very quick about security. And of course, the last point is about observability. If we are running in production, we will love to have some data about how we are performing, if it is the transaction manager availability. So we are providing graphs or charts for Grafana, Prometheus. We can use Jagger for distributed tracking, and we can send the logs aggregation using Elasticsearch, Fluentd, Fana, Kibana, and so on. So that's all. And as I mentioned at the beginning, the third component in the MicroTX is the console. So this is a very simple web console that allows us to manage the transactions, look into the Kubernetes status. This is also deployed in the Kubernetes cluster. And we have an overall view about how many transactions running, how ending complete, how are still pending, and allow us to interact with these pending transactions to terminate or to cancel the transaction. We will see during the demo. Okay, next steps for you before the demo could we go to the MicroTX Live Labs. This is available in our Live Labs platform. So you have 3 different Live Labs you can run if you are interested to learn more about MicroTX. That's the offer you have today from Ettore will be great, because it will allow you to run those Live Labs and reproduce the demos we are going to see right now, because now it is demo time. Okay, so let's start perhaps looking into the OCI console if it is not yet here, not okay. What we are going to do is we will deploy a couple of some microservices. Well, let's start perhaps with databases. We have, of course, 2 autonomous databases. We have the Department 1 MicroTX sample, Department 2 MicroTX sample I will use for my different microservices running in the Kubernetes cluster. Of course, I have the Kubernetes cluster running in OKE. And in this OKE, that's all about the OCI infrastructure we need for this demo. So if I back to my command line, I will clear this I was testing before. I will move a little bit. So I hope you can see that properly. And now we can start looking at the pods we have in the Kubernetes cluster. Everything is stored in the namespace OTMM. So let's run it. So that's great. We have here, in this case, this is just an example, very simple. So I have only one transaction coordinator pod. I have also the pod running the console. And I already have deployed the microservices I'm going to use during this demo. We have the Department 1, we have Department 2, and we have the teller for the XA. So let's start perhaps with the XA, that it will be the most interesting perhaps for you, because it's providing a strong consistency and reproducing the distributed transactions you could have right now in your monoliths. So for that, let's start looking perhaps the code. Okay, this is, though I'm going to use the samples that are available with the OTMM distribution. So you can install OTMM and you will get access to this application code. So here we can see the XA, and we are providing samples for different languages. You can see here Java, Node.js, PL/SQL. So we will start with Java. Again, there is the demos for, or the samples for different frameworks. So I think that you will most interested perhaps in Spring Boot. So let's look, for example, let's start with the teller. Remember, the teller is the microservices starting the transaction. So let's look in the teller. In the teller, we will have here the, let's look the source. We have the Java, and we have here the resources, and we have the transfer resource. Here we are importing the OTMM library. That's great, very simple. And these microservices will start the transaction. So at the end, the only thing we need to do is go down, look for the transaction. That will be something like that. And we are creating a transaction using the OTMM library. And as you can see here, the code is quite simple. Let me try to reduce, if you can see better in this way. So we have the transaction manager. Sorry for the movement. That's not very funny when you are in a Zoom, but I will try to avoid it a little bit. Okay, so remember, we are opening the transaction, well, defining the transaction using the library, and here we are transaction begin. Now we start with the code, just invoking the microservices. That's the invoke to the withdraw, and this is deposit that will be invoked to the second account. And of course, in case that we have a response that is not okay, we will roll back the transaction. If everything goes fine, then we will commit the transaction. And that's all. That's all we need in this microservice in order to implement the transaction manager for microservices functionality. Okay, that's the teller. Let's see what's happened with the microservices participants in the transaction. So we will use the department. Sorry for that. I will need to open a little bit just to find, because I want to show you again the Spring deployment. Of course, this microservice will connect to the autonomous database. So I will need the wallet. That's something that I will take care during the deployment of special complexity. And in the participants, remember that we are using the resource manager proxy approach. So we want to enable to access to the resource manager from the transaction coordinator. So there is where we are configuring the XA data source configuration. You can see here. So let's scroll up a little bit, and here you will see that we have the MTMM libraries, MicroTX libraries. This one, we are using the MicroTX configuration library, and it is so simple that we only need to use the define the data source, XA data source, and at the end we are adding this line to include it into the resource manager proxy. That's all. We are ready to work. Okay, so at this point, I'm thinking if I need to do something else. I think that it is done. I'm going to remove also some message that I receiving. Sorry, back again. That's the code. The other microservices participant is also another account, so the configuration is quite similar to this one I showed you. Okay, so let's try it. Okay, so trying, first thing we are going to do is remember security. We will need a token in order to access to the coordinator to, get acquired token. This is just a REST call to the kcloak in order to acquire the token. Okay. Now I will need to, I'm going to clear this one. Let's start asking for the current balance we have in the different accounts, just to validate it. Okay, we have here the, this is not what I was expecting. That's happened during the demo effect. Let's do some quickly. kubectl get nodes, OTMM, and I think, node spots. I think that the problem could be that this is not a production environment. The applications are quite easy just to avoid complexity. So let me do something like kubectl and delete pod -n. I did it before the demo effects and type reference. Okay, I delete this one. I'm forcing to the pods to be redeployed. And I will do the same with the teller just to avoid issues. And it will be the teller. Of course, this is not production ready. Remember, this is a demo, and it is hard to type at the same time you are thinking and talking. So, -n OTMM. Okay, that should be enough to recover my demo. kubectl get pods -n OTMM. They are here again, and let's try to get the account again. Don't see. Looks much better. Okay, this is the one of the participants. I'm invoking it just to get the amount we have in the account. I will do also with the second one. That's exactly the same in this case. And I invoke in my microservice department 2, to get the amount available in the account 2. So that's working also. That's great. If you see here the time spent, I don't know why I created databases in Madrid data center and the cluster is running in another data center. So it has some latency, no problem so far. Okay, let's try to start with the transaction. So we are going to run a transfer from the account 1 to the account 2, department 1 to department 2. Okay. And we are transfer only 50 whatever. And let's see if the transaction is succeed. That's it, succeed. Okay, that's happened with the code. It is simple to demo, but difficult to see what are the effects. So let's start. Perhaps we can go here that it is the Jagger. So let's look what happened in the last 5 minutes, for example. Find trace. Okay. And this is our teller. And we can see the full trace about this operation, where you can see the teller is invoking the transaction manager controller, and the transaction manager controller is also working with the different departments in the 2 phases that we have in the XA transaction. Cool. So its code was so simple and it is working. And as we can see here, it is following the flow I showed you during the presentation. We can go even to the, for example, to Kiali, and let's find, for example, the application grabs. This is last minute. Let's refresh it. Still trying to work. OTMN traffic last minutes. There should be more information about it. Still loading. We have see here the transaction manager working with the console, but I was expecting to find here the what it is not loading me the traffic through the OTMM. Let's do something that it is. Minute every 10 seconds, 2 minutes. Okay, I will back here later just to check if it has been finished, refresh it. Okay, let's look in the meantime to, well, I can force a rollback here, perhaps. That's something that we can, when the transaction goes fine, that's good. But okay, first let me check the transaction. You can see here the account 2 has been increased with 50, and now we can see the transaction has decreased 50. That's great. We are going to force an error, so we are going to provoke a cancel in the transaction. So here I'm going to transfer from the account 1 to the account 10. This account doesn't exist in the database, so will be generate an error. So in the second microservice, if the transaction coordinator is working, then what should happen? We will get an error in the microservice 2, and then the transaction coordinator should request to the microservice 1 to roll back the withdraw he did from the account 1. So let's run it. So deposit failed. That's great. So if we did it good, then we still have the money in our account. So I don't need any special code in order to manage this failover. That's great. Very simple for our applications. Okay, so finally, here is has been refreshed, and we can see here that we have the teller invoking the department 1, and we have the OTMM in the middle. That's hard to, because I cannot close hide this one. Yeah, you can see how the TMM is in the middle, managing the transactions between the database and so on. So something that we can deal. That's great. That's working. So perhaps last point could be, okay, go to the console. Let me refresh this. Probably I need to user A, and I should be using more simple password that I could type, but I will copy it just to avoid issues. And sign in. Not now. So we have here some information about transactions we have been running. I have active transactions. Those are some transactions I was testing before this session. And if we, for example, go to the transactions, I have a non-XA transaction pending. But if I change, for example, to long-running actions, there are some transactions that was started during my first test several time ago. So I can go here, for example, and cancel this transaction. And it should be able to send the cancel command to the status. Right now is canceling. That's great. That's the dashboard. You can see here now that our XA transaction has finally logged here. And at the bottom, we have the coordinator and the console health. Okay, that's about XA. I think that I'm running out of time. I will show you the long-running action. I'm not going to run the command, but I will show you the code just to check that it is also quite simple to simplify your applications. In this case, we are running the Trip Manager Spring Boot. Okay, that's the source. That's Java.
No, whoops! I think we lost Victor. If you can hold on for a second, we'll see. Will Victor rejoin? I think you got disconnected, so just stay with us for a second. Bea, do you want to? Okay. No, sorry, it's firm. Sorry, Herman. That was a hope that Victor was rejoined. We'll just wait. Do you want to step in for a second, Herman?
Yes. I would like to basically say that I was thinking that the MicroTX library is a great example of several of the things that we are doing at Oracle. Like, for example, if you're familiar with the pluggable architecture of Oracle databases, you will see that a lot of the libraries that we are creating and the solutions that we are creating, we're making them Kubernetes friendly, right? So you can also work, in a containerized environment. And what does it really mean for the developer? It means that you can deploy it like very, very quickly in your clusters with basically one command, and you have it deployed, and you can start using it with other pods, right, in your Kubernetes cluster. So this is a great example. So another thing that the MicroTX library also is doing great is the support for open standards, right? So Victor mentioned that it supported LRA, XA, etc. So it is something that we are trying to do all across our services at Oracle, which is basically embrace open standards, so we make it easier for the developers to actually interact with whatever technologies they are using, right? Another thing super interesting about MicroTX is the support for polyglot programming, and this is something we are also doing all across our services. We are not focusing exclusively on Java, for example, but rather giving the developers opportunities to use multiple languages. So here, this library you can consume from Java, from Python, for example, and Victor also mentioned Node.js, and so great options, right? Now, there's a big push around observability today, right? So you have to have in mind that any library that any company is producing right now, or any solution that the company is producing right now, has to provide observability, at least observability hooks for you to be able to understand what's going on. For sure, you want to have a proper dashboard, right, where you want to visualize everything, but it's not enough that that solution provides a custom dashboard. But basically, you need to be friendly with everything that the developers are using today for observability. There are a lot of technologies that are popular nowadays, like Grafana, Prometheus, etc. So this library is friendly with that, and even goes all the way up to the possibility of doing tracing, like Victor showed today, right? So yeah, so those are my comments related to MicroTX. I find it very interesting as a library.
Thanks, Herman. I backstory a lot because my Mac crashed. That's never happened to me, but step when I am presenting,
This is live, so.
Yeah.
This is the point Windows users start shouting in glee, going, "Oh, Macs do crash." So
yeah, that's good point. Yeah.
Back to you, Victor.
Okay, I was just finishing. I'm trying to, because everything was rebooted, so I need to find where I was my visual code and so on. So
do you need more time, Victor? Because there's no.
No, I was just to show the long-running action code. So I think that the demo is we can run also the demo for long-running actions, but I need to repeat everything, and probably you get the concepts. As Herman was saying, we have the libraries. It is very easy to integrate our MicroTX with your applications. You don't need to rewrite code. You only need to use the interceptors. You use the library using the annotations, and only a few codes you need to add to your existing applications, and you will save a lot of time. You don't need to write your compensation code. You don't need to write or take care about failovers like mine right now with the Mac. And at the end, that's the idea for today. Keep in mind that you have one tool that will avoid you to be dealing with the complexity of your transactions. So I think that the goal was matched with the short demo I ran with the XA. You see how to complete with a commit. You see the rollback. You see what Herman was commenting when I joined, that the observability is also critical. If without the observability, I can show you this demo, and you cannot be sure that I was using the library using this technology. You can be sure that I can track everything in my system and be aware what are the pending transactions, cancel pending transactions, and then that's very simple for developers and very simple to implement. That's all from my side.
Cool.
Thank you.
Thanks.
Thank you, Victor. All right, so we are back now. The session 2, we have Herman, who will explore together with you the integration of an event mesh with the autonomous database transactional event queues and the Apache Kafka. Herman, whenever you are ready, over to you.
Yeah, hello, thank you. All right, so let me start by sharing my screen, and then we properly get started. One sec. For those of you that haven't seen my sessions, okay, so my name is Herman Viscuso, and I usually cover Oracle technologies, especially focusing on autonomous database, okay, and I do sessions that are rather technical. I like to do demos, stuff like that, and I used to work on a similar line of work for Amazon before joining Oracle. So having said that, let's cover transactional event queues. I'm not sure if you heard about advanced queues in Oracle. This is like the latest iteration of all the queuing support that has been around in the Oracle database for some time now, and it has many advantages, and I would like to comment on that. But first, I would like to say that this is a great combination that we're doing this with Victor, in the sense that we are covering a transaction manager for microservices, and now we are covering message passing with microservices. Okay, so 2 very important topics for microservices developers that we wanted to combine and put together into this session, right? There are obviously more things that you need to worry about, not only these 2 things, but this is basically building blocks of microservices development. Okay. So let's start by a couple of slides. This is mostly demo, right? But we have a couple of slides that we wanted to share with you. So what is a transactional event queue? So this all started with applying this transactional outbox pattern, okay? So I'm not sure if you heard about Oracle transactional event queues and AQs, but it comes from these patterns basically, and this pattern is from the world of microservices. This is a documented pattern, and here what is known as event sourcing. Means that every time that you touch the data, right, you need to send an event to other microservices. So suppose you change a record or you change, I don't know, a customer or something like that within the application, you need to send an event, right? So those events are separate from the database. So you need to make sure that when you do that, both the data and the event are sent atomically. You don't want to touch the data and the event fail, right? And suddenly you're not sending, the right message. Something is going on. So imagine the broker fails, like a Kafka broker, for example, and fails to queue the message, right? So one solution is to use the transactional capabilities of the database by updating a table of events together with the modification of the data. So as you can see here in this graphic, you have like an order table. So suppose that you're processing orders, right? And you also want, when you create an order, you want to send an event. So you can do that in the database as a single transaction, right? You can do this insert in this outbox table and create an event. And now if this table is integrated with message brokers like Kafka or with systems that process this type of messages, then you are done. You basically have an implementation for this pattern. And this is what transactional event queues is about. This is not using two-phase commit, so there's no blocking two-phase commit, and the order of messages is preserved. This is the basis of the technology, and it's an evolution of what used to be known as Oracle Advanced Queues, if you're familiar with it, okay? All right. So these are some of the things that are supported in transactional event queues. So you have persistent queues, because these queues are tables. They are in the database, so they persist and they have all the guarantees of the database, which is good. They are in memory, so they are super fast. They guarantee exactly once message passing, because they support this pattern that's basically based on that, on having that kind of support. And the message ordering is conserved as the producers are sending these messages, right? So you can think of these setups as a producer-consumer setup, where if you're familiar with I don't know, maybe MQTT protocols or Kafka or other message brokers, RabbitMQ, etc., you will see that you can create a topic, which is basically, you can consider it like a channel. For example, if you're familiar with, I don't know, maybe Slack, right? A Slack channel, you can consider it as a channel. And then you have producers and consumers of those messages sent to the topic, right? The producers will put messages and the consumers will basically take messages out. And this is what's called a pub-sub environment, right? Or a pub-sub technology. So this is all provided by transactional event queues, and this is all based on open standards. As I mentioned before with MicroTX, that I like the fact that it's basically supporting open standards. This is also supporting, for example, JMS, the Java messaging standard, and it's also interoperable with Kafka, which is the most popular message broker out there in the open source community. Okay, so this is enterprise grade, and this is super fast because this is using in-memory in the database, and it's providing all the guarantees of the database, and it's just basically faster than having like a separate broker. And we'll go a little bit into that and how we can basically work with it. Okay, all right. So let me just move forward. Let me just show you the whole thing before going into the animations. All right, so we have seen a bunch of ways to use transactional event queues. So lots of basically, in our experience, there's a lot of language support and a Kafka-like architecture with topics and partitions. So as I mentioned before, the topics, you use them as channels, and you can produce and consume messages within the channels. But then you can also provide partitions where you basically want to scale this architecture. So each database instance in transactional events queues acts like a broker. So it's basically a broker. And you can connect multiple databases together and have messages or events propagated across database instances or across brokers, if you want. And you can have your consumers connect to their nearest database instance. So we can really scale out to massive environments, because if the consumer is close to the database instance, then that message passing will be very, very, very fast. And it doesn't matter that then you have a broker that is maybe far away from this setup. You can basically connect them, right? And create what we call an event mesh. And we will go into that later. So there's a Kafka connector that we provide. This is an Oracle technology. It's Kafka, called Kafka Connect, right? So you can join Kafka clusters into this whole event mesh with bidirectional interoperability between Kafka and transactional event queues. We will go into that in the last part of the demo. So transactional event queues has a Kafka Java API and Kafka-like REST APIs. So it's very similar to use. We actually design it so it could be at the code level, could be replaced very quickly if you have a Kafka implementation, like a Kafka-based Java application. And you can use Kafka clients directly against transactional event queues if you want, okay? So this is the basic setup, producers, consumers, the broker is the database, and it's all interoperable and connectable to other Kafka instances or other transactional event queues instances. All right. Okay. So let's move. Finally, I mentioned the possibility to create a mesh. So here we have on the left Apache Kafka, Apache Kafka broker, and there are some queues that are being shared. Queues of messages that are being shared between transactional event queues. So for example, you could send a message to a topic in Apache Kafka, and if you properly configured Kafka Connect and you created what we call a sync, an event sync, okay, you will be able to consume that message from transactional event queues within the database, and the other way around. So this is very, very powerful because it is bringing the message system and the message brokering system into the database and very close to the database with all the guarantees that the database provides. Okay. All right. So we'll go through a demo. If you take a look at the bit.ly link that is in the top right, we will do almost all of lab 1. I did the basic setup, which is creating a user group within OCI, creating a policy. So it's the super basic setup. But we will set up the services with a script. We will clone this repo here. So this is a fork of the lab repo. I created this fork because I wanted you to be able to run this within Cloud Shell. So you go to OCI. You click on the top right, there's something called Cloud Shell, and you have like a Linux system there up and running. And I wanted you to be able to just go there and do that without setting up stuff in your computer or anything like that. Just go to Cloud Shell and run everything from Cloud Shell. So you'll have to clone my repo if you want to do it from Cloud Shell. The original repo is more prepared to run it from your own machine, right? So if you have a Mac or a PC and you want to do it from your own machine, maybe you should go ahead and try the original repo, okay? We will do lab 2. We will build Spring Boot microservices with Kafka. So we will create a producer and a consumer. We will deploy them and we will launch them. And we will create a message. The producer will create a message, put in a topic, and we will consume a message. And we will do all of this with Kafka, not with transactional event queues initially. This is lab 2. Then we will do lab 3, where we will do exactly the same thing, but with transactional event queues. We will create a topic, we will deploy a producer and a consumer, and we will send a message from the producer will put a message in the topic and the consumer will consume it, okay? And then we will do lab 4, which we will connect Kafka and transactional event queues, an event mesh with Kafka Connect. So this is basically enqueuing a message in a Kafka broker and dequeuing it or consuming it from transactional event queues. This part is not working properly. I just need to give you a heads up. There's an error here, but I wanted to show it anyway because we are just about to fix it. And I wanted you to see, basically understand the concept, okay? So just a warning there. And also this demo in general is very, very delicate, to put it some way, right? So a lot of things might fail. So I hope we have a good run in this case, but a lot of things can fail. All right, so let's leave this for the end, okay? The observability part. because I just want to close with that. All right, so let's go to. So here, what I did is just I click here and I went to Cloud Shell. Okay. So what I'm going to do right now, just give me 1 sec. I'm in Cloud Shell. So if you have an always free instance, you can also go to Cloud Shell. I am just going to create a directory where I will clone that repo that I mentioned before, right? So I'm going to clone my repo from, this is basically a direct fork with some fixes. Some fixes, for example, are related to supporting ARM, because Cloud Shell migrated to ARM-based processors, right? So you need all the libraries to be ARM, ARM specific, right? So other fixes too, but basically that's one of the main changes that I did here in my repo. I'm going to just go full screen for your benefit, probably increase this font size a little bit. All right, so we cloned the repo, right? So right now we are going to source some environment variables. Okay, so let's do that. This is basically setting up like what lab home means. If I do cd lab home, I go to the lab home, a lot of environment variables that we want to basically have there for the lab. And remember, we are running that lab that I showed you before. In the top right, the bit.ly link, you can follow by yourself if you're interested. I'm also going to source the bash rc, which is basically some scripts that we are putting there. And now what I'm going to do is I'm going to run the setup, and the setup is going to install Kafka. It's going to install a Kafka broker. It's going to create an autonomous database within OCI. So one of the advantages of Cloud Shell is that it has an OCI CLI pre-configured for you. So this is basically connected to your tenancy, right? So you can start doing things over your tenancy like right away without any kind of extra setup. So I'm going to run the setup. Let's see how it goes. It's ask me for the OCID. So this is basically what you need to provide. You need to provide an OCID of your user. You can get it from the profile in your here in OCI. You go here, this top right, this is a person. You go to profile and you can fetch your OCID from there. Okay, I'm passing it. It will verify that it's okay, etc. And you need to provide the password, which is the database password that you will create for that autonomous database that is going to be created right now. So it's asking me if I want to use always free autonomous database. I'm not going to use always free because I have like a full-blown tenancy here. So I say no. You can decide to use always free if you have limits. It will check the limits and it will tell you if you are if you can actually run the lab. Basically, we'll check that the limits are okay. Okay. Now it's installing a GraalVM Java 11 image. So there's some Docker installation here, install images, etc. So this is all based in Docker. All right. And I think, okay, now we are asked for the database password. Okay. So let's enter a very simple password. Let's see if it gets verified. Okay. So right now it's creating the autonomous database. We will take a closer look at it from the OCI UI later. Okay. But basically, creating an autonomous database takes, if it's a serverless deployment type, takes around 2 minutes to give you an idea. Okay. So let's wait a little bit. Remember that we are doing all the steps here, and we'll have to have some patience, but we're talking about minutes, right? For deploying the database, around 2 minutes, but then when we start deploying all the Java applications, around 6 minutes, to give you an idea. That's what I wanted to save the observability slide so we can take a closer look at that. Okay. All right. So as you can see, this lab is based on multiple scripts that are basically making life easier for you. This is using Terraform, for example, as an underlying, a script or technology to basically create the database, the autonomous database for you, right?
Herman, just to, there's a couple of questions coming in. They can download this script, right? People are just wondering if they can get a copy of it.
Yeah, absolutely. If you clone the repo that I showed before, you have all the scripts, all the source code, everything. Okay. So you can take a closer look. There's a script called main setup that basically orchestrates everything. Okay.
Cool. Thanks.
Sure. Okay. So let me see. In the meantime, if I can open a second Cloud Shell, because sometimes I want to monitor things. So I'm going to open a second Cloud Shell here. You can actually do that, which is good. All right. So let's see if we can see. Let me move this to another screen. Let's see if we can see the compartment. Yeah, you can see the compartment here. Right. So this is all going to be installed in this compartment. It's going to be created for you, TxEventQ lab. So then when you need to destroy resources, it's very easy because you just go and destroy everything that is inside TxEventQ lab, okay? So let's go back. 3 minutes, still creating. Let's see if we can see it already. It's going to be called TxEventQ lab ATP. Okay, as you can see, it says provisioning. So here I'm taking a closer look at the database that is being created by the Terraform script. It's taking a bit longer than usual. So let's see. We definitely need this to continue because, as I mentioned before, the transactional event queues, the system is within the database, okay? Okay, so now it's available. So this should keep going in a sec, okay? There you go. So it went from provisioning to available. This is a database that was just created via Terraform, all right? So right now it's doing a deep database setup and a Kafka setup. The database setup is creating, permissions within the database to use transactional event queues. It's creating a few grants. It's running, basically running SQL over the database, okay? So the database setup has completed. We are going to take a closer look at that later if we have time. What's happening to prepare the database for transactional event queues, and specifically for this lab. In this lab, we have Java applications that are acting as producers and consumers of messages. We have two applications, producer and consumer, that do that with a Kafka topic, and we have two applications, producer and consumer, that do that with a transactional event queue topic. Okay, so one application puts a message, the other application, the consumer, reads the message. Very, very, very simple. So we have the Kafka setup being done right now. So this is installing Kafka, because if we want to show you Kafka, we need to install Kafka. We need a Kafka broker, we need basically to have that deployed. So this is happening live right now. Let's see if how long it takes. But in the meantime, now that we are waiting for that, let's go ahead and take a look at the observability slide. All right. So let me go back to that. Okay. I'm just going to keep this kind of view here where you can see, not full screen, because I want to quickly come back to the demo. But basically, since transactional event queues are running within the database, as you can see here on the left, right? You can create observability setups, like for example, a Prometheus exporter that it's a perfect bridge between Grafana and the database in order to basically have a dashboard where you can see how these messages are being queued and dequeued, and the throughput of those of those actions, on how the messages are being put into those topics, and how they are being fetched, extracted, and consumed, right? So since all of that is in tables in the database, you can create an exporter similar to the unified observability project that you have on the top right there. I have covered this extensively before in several sessions, the unified observability. So the unified observability setup, what it's basically doing is creating a Prometheus exporter over the database, and creating like an endpoint for Grafana to be able to show what's going on in the database in dashboards. So you can also do that with transactional event queues. You can create an exporter that is reading into those queues and what's going on, right? And then you can visualize all of that in Grafana. And all of these technologies here, when you take a look at Prometheus and Grafana, and these are all external tools. They can be run somewhere else. You don't need to be within OCI to basically run Prometheus and Grafana and a Kubernetes cluster. And this is what I really like. The way in which these exporters talk to the database is via what we call the Oracle Database Operator for Kubernetes. This is an open source framework that Oracle releases that allows you to quickly, in a Kubernetes cluster, install a controller of Oracle databases. So, for example, you can quickly connect and even provision, right? You can deploy, create a database, destroy it, etc., from within Kubernetes in just a couple of minutes by installing the Oracle Database Operator and managing all the lifecycle of a database. So this is what's being used as an underlying technology to connect to autonomous database. Okay, let's go back. Okay. So as you can see, we have Kafka setup has completed and setup verify completed. So what you want to see is this setup verify completed. If you have Kafka setup still executing and you stay there for a long time, maybe it doesn't end, you can try to cancel, just Control-C, cancel, and run the setup again. Okay. And that means that probably there was some sort of race condition there by installing any of the Kafka elements. All right. So we have it up installed. So now we need to verify that this is up and running, okay? So just to give you an idea, Docker images, when I started, as you can see here, I haven't run it before, but Docker images was empty. So basically nothing was coming out of Docker images before running the setup. And now if I do Docker images, I have a CP server, a CP schema register, and a CP zookeeper. This is very, very important for Kafka. I have Kafka Connect, which is basically the technology to create the sync. I have a Graal VM because I want to have a Java VM there. And I have a component, which is what we created to connect Kafka with transactional event queues, basically the application that creates the connection, okay? So right now I'm going to run a command that, remember that I installed environment variables. So one of those variables basically was providing this command, which is Kafka status. I'm going to run Kafka status, and you can see that I have a broker, I have connect, schema register, and zookeeper. So this is what you should be looking at, right? But we haven't started Kafka. So as you can see, there are no ports. We don't have private IPs there. So these are ready to be started, these services, but they are not running. They are not on a specific IP address. Okay. So let's do Kafka start right now. Okay, Kafka start. Okay, and now if we run Kafka status again, you will see that the services are running. We have ports, but we have the second one, which is the connect, that says starting, okay? So that one, we need to see it as healthy for us to be able to continue, because this is a service that we need to use, right? So once it's healthy, we are ready to go. and we are using private ports, and we are not using any public IP here. So this is a completely private setup. So let's run Kafka status again a couple of times. Let's wait a little bit. Please have patience, bear with me. This is a live demo and we are running the commands live, and things take some time, you know, depending on what we're doing. But this should be fast. There you go, healthy, okay? Perfect. So right now, what we're going to do, we have Kafka up and running, but we don't have a topic. I mentioned before that when you are going to produce a message and you're going to put a message from a producer, and then you're going to consume a message, that has to be done over a topic. So let's create a topic in Kafka. And remember, we are still not using transactional event queues. I'm doing this because I want to show you how similar this is when we go and do it with transactional event queues, okay? So Kafka app topic, transactional event queue. So this is, if you take a look at the script, this is basically using a REST API to connect to Kafka and create a topic, okay? So we created a topic called TxEventQ topic 1 within Kafka, all right? Okay, so we have a topic now. We can start to dance, to put it some way, you know, to do stuff. So we need applications. We need a producer and we need a consumer. So I'm going to go here to the Spring Boot Kafka directory, where you will find 2 applications and a producer and a consumer. And I'm going to first deploy them, and then I'm going to launch them, okay? So before deploying, I will build Kafka MS build. These are Java applications that are prepared to connect to the Kafka broker here. And in the case of the producer, put a message in that topic that we just created. And in case of the consumer, read a message from that topic, all right? All right, so this is completed. This is good. Now we're going to deploy the producer. Okay. Let's deploy the producer. Remember, deploying is not launching, right? We just deployed it. It's good. And now we are going to launch the producer, okay? So let's launch the producer, see if everything is okay. Waiting for producer running. Kafka producer microservice is running. We're using a Spring Boot. We're creating these applications of Java microservices, and they are very simple, but you can, if you take a look at the code, you can extend them and you can create something more complicated. So let's take a look at the logs of this Kafka producer. We can do something like this. Container logs, Kafka producer, show me 6 entries. And as you can see, it looks good. Yeah, it looks good. Yeah, so perfect. And now what we're going to do, I was trying to see if there's an error here. I don't see any error. What we're going to do is, we have this microservice up and running. This is a producer, but the code is basically exposing an API to send a message, because I wanted to, give me one sec, there you go. What I wanted to have is an API that allows me to basically write the message, right? Suppose I want to say in the message, I know, hello world, right? Something like that. I wanted to be able to pass that to the API and say, hey, put a message in that topic. So that's what we're going to do. So this is a curl command, content type application JSON with a body where we say, okay, the ID of this message is ID 1. The message just says message 1. And this is the endpoint where this microservice, this application is up and running, which is localhost 8080. Okay, and the basic API call is called place message. Okay, so let's do that. As you can see, we have ID 0 successful. So we have placed a message in the topic, but nobody has consumed it so far. So now let's go to the consumer part. Let's do this. Kafka deploy consumer. Remember that we did a general build before, so we don't need to build it. When you do the general build, you build both. Okay, so the consumer has been deployed, and now we're going to launch the consumer. Now the consumer is not using an API for me to tell it, go ahead and consume, but it's basically consuming directly. So we will take a look at the logs and see how it consumed the message, okay? So I'm going to launch the consumer. Okay, consumer microservice running. It should have consumed the message already. So let's take a look at the logs. And as you can see, you take a look at the last line here of the logs. You will see that we have in the logs a message that says, okay, ID 0, message 1. I got my message 1, okay? So basically, and here you can see that it basically went into that TxEventQ topic 1 to fetch it, all right? So we have a Kafka consumer and producer and broker up and running here, right? In Docker, in Cloud Shell. Now, let's do the same with transactional event queues. And please take a closer look at how similar this is, because transactional event queues have been prepared to be a direct replacement at the code level for all of this. So the implementation, the topic creation, etc., it's all very, very similar. And hopefully we'll take a look at the code if we have enough time. But the only thing that you will notice as different now in the interaction is that, for example, I'm going to create a topic in transactional event queue. So I'm going to connect to that autonomous database, and I'm going to tell the database using the transactional event queues functionality, hey, create a topic. You are a broker now, create a topic, okay? Same name. And what do you notice here as different? We're being asked for the database password because transactional event queues runs in the database. I need to connect to the database, right? So I'm going to provide the password that we provided when we created the autonomous database. So let's see if it goes okay. Connection is taking some time. Okay, created topic, transactional event queue topic 1. So now we are replicating what we did with Kafka, but with transactional event queues, and we have the topic. But still, we don't have a producer and we don't have a consumer, okay? So let's go to those two microservice applications, which are very similar to the ones that we already ran for Kafka, but they connect to transactional event queues. Let's go to that directory, which is where we have those two applications. All the source code is available for you. You can go ahead and check how the Java code, etc., etc. So this is very customizable, to put it some way. So now I'm going to build these two applications that will connect to the database using transactional event queues. Okay, we're building. This builds both the producer and the consumer, same way as we did with Kafka. And now we're going to deploy the producer. Okay. We want this application that will put a message in the transactional event queue, same like we did with Kafka. Okay. And we deployed it, but now we need to launch it. Okay. So let's launch the producer. And now in order to have them separate from the Kafka microservice that was the producer, where we used that API, we did the curl and we sent it, we sent a message. Here we use a different port. So I think it's 8090 instead of 8080, okay? So we launched the producer. Let me see in the container logs if everything is okay. We can do the same thing like we did with Kafka. Take a look at the 6 items in the logs. Started a Kafka producer application, 5 seconds, JVM running. or Kafka producer application running. Looks good. And now we will do that curl, but instead of connecting, we are using also place message, but instead of connecting to 8080, we connect to 8090, which is the transactional EventQ's producer API that we are exposing. Okay, we are going to send a message that will read TxEventQ message 1 instead of just message 1. All right, now enter. Okay, ID 0 successful. It got assigned the ID 0. Okay, I'm seeing an issue here with the IDs not being passed for the message. So remember, we said it should be ID 1, but it got assigned ID 0 for the Kafka example. The same happened, so we'll have to take a closer look at that. But it's not a big deal because what we're really interested in right now is in seeing that the message is being sent. Okay, so we are going to deploy the consumer right now. We are going to consume this message, and also using transactional EventQs. Okay, deploying. Okay, it's executing. Let's wait. Okay, completed. And now launching the consumer. Remember that the consumer is not using an API. It's exactly the same. We're replicating, the consumers and the producer at the code level with just the minor changes to use either Kafka or transactional EventQs. The consumers will go ahead and fetch the message without using any API or anything like that. So let's launch the consumer. Okay, looks like it went well. And now we are going to take a look at the logs to see if we can find this message here, this TxEventQ message 1, okay? Okay, that error is okay. This is Kafka version properties is not there. So let's see if we can find it. Let's do it again. Yeah, there you go. So here you can see that it says message received, message, TxEventQ message 1, using key 0, etc., etc. So the consumer basically fetched the message. All right. Okay. So let's see if we are doing okay with time. Let's see if we can do something like this. Database actions. So this is the database that is hosting that transactional EventQ's functionality. Let me see if we can connect to it. I think we're doing fine with time so far. We just have the last lab pending, which is the Kafka Connect sync, which is basically connecting Kafka and transactional EventQs to work together as an event mesh. But before that, I wanted to show you some of the SQL within the database, in case you are curious about how to take a look at the topic names, the user that is being used, the subscribers, etc., etc. So let's wait. Waiting. Okay. So I'm not sure if you're familiar with this functionality, but in Autonomous Database, you can go to database actions and you have a whole lot of things, especially if you go here to view all database actions. And I'm just going into the SQL functionality. It used to be called SQL Developer Web. And now I can just run SQL, like right here, okay, over the database. So what I'm going to do is I'm going to run a select statement, and I'm going to read the all queues table. It's basically show me all the queues, obviously of transactional EventQs. Okay, so here there are queues that the database uses internally. So the system is so good that the database uses it for message passing, right, for internal functionality. But also you can tap into it and create your own queues, right? And here you will see that we have the queue table. It's the same name of the topic that we created. This is a normal queue. And we have a user that is TxEventQ lab user, okay? Remember that we had a phase where we did the database setup and we were waiting for that database setup to be done. We were creating this user, etc., okay? Creating grants for this user to be able to operate over a transactional event queues, etc. All right, so now if you run also a select asterisk from DBA queues, this is another one that you can take a look at. And you basically say, tell me the DBA queues where the owner is this user, you know, our user, transactional event queue lab user. You will see that you have owner, you have a name, which is the topic, a table where the messages will be placed, queue type, maximum number of retries, retry delay, queue enable, the queue enable, retention, etc., etc., etc. All right. So this is interesting if you want to take a closer look at SQL. All right. So before going into the last part of the lab, let me go here to Visual Studio Code, and let me show you a little bit of the Kafka event producer. So remember that we created an application that was producing a message and was placing it in Kafka, not in transactional event and queues. That's how we started. So if you take a look at the code, you will see that this is a public class. It's very, very simple. We have a constructor, which is called Kafka event producer, and then we have a validate data and send data event, okay? So if we go here, you will see that we are sending the order for processing here, right? And this is basically creating a record, which is a producer record that has the message. And then using this Kafka producer, sending the record. So this is basically the producer sending a message to the broker, okay? So let's take a little bit of Kafka producer. It's a Kafka producer service, okay? So you can see here. Now, one line of code for the producer to send the message, which is obvious. We don't need to do much more than that because the system is taking care of retries, you know, et cetera, depending on configuration. Now, what about the transactional event queues producer? And the library is called OKafka, okay? If you're interested, instead of Kafka, OKafka, right? So if you take a look, it looks very, very similar. It's stuff that we are using of Kafka, and it's called OKafka Producer Service. So as I told you before, it's more or less a one-to-one replacement. And we are also creating a producer record, right? Exactly the same. And we are saying producer send record. So the code change is negligible. Basically, if you want to adapt a Kafka code to a Kafka, you just need to basically import the Kafka libraries instead of the Kafka libraries, and you are all set. Now, if we take a look at the consumer, and let's start with the Kafka consumer, you will see that we have a listener over the topic. So the consumer, instead of saying, you know, go and check now, instead of doing polling where you're doing go and check now, go and check now, go and check now, what you're doing is creating a listener over the topic, and you have this consumer listening for messages on this topic, and then basically the queuing the message if they are set up to do that. And if you take a look at the actual method, it's called receive, right? And when it gets a notification or basically a warning that there's a message in that topic, it will just end up here in the receive message, and it will just, you know, as you saw in the logs, basically say, this is the message, you know, this is partitions, offsets, etc., etc. Okay, so it will do this for each message that arrives at the queue. And if we take a look at the OKafka counterpart, you will see that we have consumer records here, and here we're doing a for loop, and here we're doing some sort of polling to actually receive the record and the message. Okay, so the only difference here is that we are not using like we did here, like a listener, right? I think that's supported, but the implementation here is not using a listener, but basically, you know, going into a for loop of available records and basically receiving the records. Okay, all right. But as you can see, there's some sort of listening to the events, because this is subscribing to the topic. So as you can see here, this the consumer is subscribing to the topic, and you will end up here processing records when there are actual topics in the there are actual messages in the topic. Okay, so you will not be polling here all the time, but basically when there's something in the topic. All right, so in practical terms, it's basically the same, right? And when it comes to code, you just need to basically import the Kafka libraries. All right, so let's go to the last part of the demo, and we are done. Okay, we go back here. All right, now if we do Kafka status, okay, we have a healthy environment. This is what I showed you before. And now we're going to do the Kafka Connect code, and this code is also available for you in this directory, Kafka Connect TxEventQ. And now what we're going to say is set up Kafka to transactional event queues connection. And what this is saying is that I'm going to run it now, entering the DB password. Okay. What this is doing is saying, okay, I have TX event topic 1 in Kafka. I have a TX event topic 1 in transactional event queues. I want them to be able to replicate messages back and forth. So basically, it is connecting these two topics, saying, actually, this is the same, and this is part of an event mesh. So if I put something here in TxEventQ topic 1 in Kafka, I want the consumer to be able to consume it from transactional event queues in the same topic name, and the other way around. Okay, so this is what we are trying to do here. Remember, this is the part that is not working correctly, but I wanted to show it to you because we are going to fix it soon, and basically it will basically be working, right? It's not working right now because of some adaptation that we're doing for Cloud Shell. Okay, so as you can see, I think that the error is related to this. It says that the leader is not available, right? So probably there's some sort of the leader not being recognized in Kafka. In Kafka, the leader concept is important. It's basically what leads the message brokering, and apparently that could be related. Okay, but if we do Kafka Connect status, which is something that determines the status of the Kafka Connect sync using Kafka Connect, it says that it's good, that it's up and running, that it's connected, that it's in the port, etc. But still there's an underlying problem that we need to figure it out. So how will it work? Okay, it will work like this. You place a message like you did before in Kafka, not in transactional event queues, in Kafka. See that we are using 8080 and we are placing a message, and you should be able to consume it from transactional event queues. And we are going to try that. We have, you can consume it from an application like we did before. You know, we have a consumer application in transactional event queues, but this is polyglot. You can also create a consumer from SQL, from PL SQL. And this is an example that we have here. Transactional event QDQ is calling a PL SQL that it's a consumer, and it will try to consume. You know, transactional event queues is within the database, so consuming it from PL SQL is very, very straightforward. So we're going to do that, and it's going to fail, okay, right now. DB password, workshop. Okay. So we located the topic, no messages to the queue. So what is happening right now, what is failing right now, is that the message that we place in Kafka is not passing properly to transactional event queues, right? And it should, right? It should be able to be dequeued right from here. I want to show you that SQL, and we are done. Okay. Okay, yes, this is good. So this is PL SQL, okay? We are setting some options on how to dequeue message properties, etc., etc., etc. And we are using, give me one sec, a store procedure called dbms aq dequeue, okay? So this is something that comes with the database right for you to be able to actually go specify a specific topic and dequeue a message from that queue. And that's it. It's very easy. So the queue, basically, you pass the parameters and you have your result. And you can use it. You're in SQL. You know, you can use it however you want. You can obviously also do this from a Java application. All right. So yeah. So that's it for me. I already covered the observability part. So yeah. Back to you, Violeta. I'm not sure if we can tackle questions. Q&A.
Herman, you said at some point that MicroTX helps with coordinating transactions that spawn multiple microservices, and that the TxEventQs with messages passing between them. So as a microservices developer, what other areas do we need to worry about?
Victor mentioned some of that when he went through his presentation, where he said you can have one database per microservice, right? And that is a big one, because when you have that kind of setups for microservices, you need to have expertise in your team to basically be able to handle different database technologies. And you need to have your, I don't know, maybe if it's message brokering, your Kafka experts, you know, if it's MongoDB, your MongoDB experts, if it's, I don't know, Snowflake, your Snowflake experts. And also, it's not about expert, but it's also different security model, you know, different SLAs. So it's a big mess. And I think that's where the microservice developer has to be very careful at trying to leverage any technology that allows you to work with multiple workload types. Like, you know, the Oracle database, it's a converged database. Autonomous database is a converged database, and you can run multiple workloads as pluggable databases. You can have your container, and you can have multiple pluggable databases, and you can have multiple microservices behind those pluggable databases. But if you have to patch all of those databases, you just patch the container, right? And that's it. If you have to apply security, you apply security to the container, and you don't have to do this like on multiple different technologies. And if you consider transactional event queues, you can also be doing message passing between those microservices using transactional event queues within the database. So you don't have to go outside Kafka broker, come back, maybe the Kafka broker goes down, something like that. As long as the database is up and running, you can be passing messages between these databases behind microservices that are all in the same place, right? Or in this or under the same technology. Victor, I'm not sure if you want to say something.
No, that's perfect. Yeah, one of the issues that some customers are facing is that they are introducing a lot of new technologies, new databases, and they need to learn how to manage those databases also. And of course, when the microservices architecture start growing, then you will have not 2, 3, you will have hundreds of databases to be managed at the end. And as Herman said, then you will need to patch, you will need to upgrade, you will need to take care about security, high availability, and so on. So using multi-tenant architecture, that's great also. Of course, autonomous databases take care about most of those issues. You don't need to manage all of them. But also, if you don't want to use autonomous, you have the option to use multi-tenants. Put PDBs on top of one single database, one PDB for each microservice, and then you need to only manage one database, patch once, update once, apply high availability, recovery, and so on. That's quite easy. That's great for developers, and also not for developers, also for DBAs, because they save a lot of time managing these kind of issues. Yeah.
Yeah, absolutely. And the good thing is that maybe not the good thing for us, but the good thing for the developer is that you don't have to necessarily be within OCI. If you're using Kubernetes clusters, you can deploy MicroTX in a Kubernetes cluster that it's in a different cloud, right?
Absolutely.
And you can use Aura Operator to basically do the lifecycle management of Autonomous, even if it's within OCI, because you can connect, to the database, and that's it. You don't have to be within OCI.
Yeah, that's a common question from some customers, that it's okay, you have the database operator for Kubernetes, but Kubernetes is not the right place to run databases. So that's true. Even OpenShift has requested to the customers to don't run databases in the Kubernetes cluster. So the operator is not able only to manage databases running in the Kubernetes cluster. It is also able to manage databases outside of the Kubernetes cluster.
That's correct.
You can provision an autonomous database using the Kubernetes API, and for developers that's great, because I don't care where the database is running. Just I want to use a declarative mode just to deploy the application, and if it is running in Kubernetes, good, and it is running autonomous, even better. So let's try. I recommend you to try that, because it's great for developers also. Yeah,
precisely. And one final comment is that in order that developers see how we are trying to open up the game, like today you can go and create a Kubernetes cluster within Azure, for example, install the Oracle Database Operator, and operate over an autonomous database that is also running in Azure, right? So
that's
it doesn't have to be OCI.
Because you can forget also about Terraform scripts. You can use only the Kubernetes API, and you don't need a Terraform script to provision a database that, okay, again, you will need to maintain and so on. That's great. You only need to create your YAML file, deploy, and use it.
It's a controller. That's right. It's a controller. It's very different from just a plain Terraform script. Okay, I'm not sure if you want to tackle questions, Violeta, from the audience, or.
I think we covered pretty much all. And I know that we are over the hour.
Yeah.
I would like to quickly do the useful resources part, and then we can close the call. And in the meantime, if we see any questions, please interrupt me, and we can.
Also, please send to Slack. Please send to Slack, because we are monitoring the channel. We can continue the conversation over there.
Thank you. All right. So, if we don't have any other questions, I would like to thank you all for sitting here with us until the end. I know it was a lot of time, and it is not an easy session, but we hope that you found it insightful and that you learned a lot from our speakers today. Thank you, Victor. Thank you, Herman, for your time and for the great presentation that you've done today.
Thanks, everyone.
We hope to have you back soon at Cloud Coaching.
Thank you. Yeah, absolutely. Anytime.
All right. Thank you, and enjoy the rest of the day. Bye-bye.
Bye-bye.
Bye.